Locked in a trade fight with Donald Trump, the Carney government is now reconsidering its multi-billion-dollar purchase of American F-35 fighter jets. You may have heard that Lockheed Martin is offering new jobs for Canada, but only if Ottawa sticks to its plan to buy 88 F-35s. That review is happening for one clear reason: Trump's trade war with Canada. At the same time, another aircraft quietly entered the conversation. The story of the Saab Gripen has always been about practicality, a fighter built for countries that need real combat capability without burning. Through massive defense budgets, for years, it was seen as sensible, balanced, and affordable, but never extraordinary. Then the data started changing. Heat signatures dropped into ranges normally associated with stealth aircraft. Operational range stretched far beyond what a single-engine fighter should be able to achieve. NATO analysts noticed something was wrong only after the same results appeared again and again across multiple tests. This was not the result of a loud redesign or a headline-grabbing weapons program. The force behind it came quietly from a company better known for luxury engineering than air combat. Rolls-Royce reshaped what the Gripen E could do, largely out of public view. For most of its service life, the Gripen E was viewed as a capable fourth-generation fighter, optimized for cost, maintenance, and flexibility. Analysts praised its low operating expenses and its ability to operate from short, dispersed runways. Yet few believed it belonged in the same category as high-end stealth jets. That perception remained while a deeper transformation unfolded beneath the aircraft's familiar exterior. The bottleneck was not the airframe, the sensors, or the weapons. It was the engine not in raw thrust, but in how heat, airflow, and control logic were managed at microscopic levels. Instead of replacing the General Electric F414 engine, Sweden chose a far more subtle path. Rolls-Royce was asked to redesign what lived inside the engine, targeting internal behavior rather than outward form. There were no public announcements and no major disclosures. Engineers focused on airflow channels, thermal distribution layers, and digital control systems operating at extreme precision. Fractions of a millimeter and milliseconds of response time became decisive. From the outside, nothing changed. Paper, the engine looked the same. NATO planners and even much of Sweden's political leadership were not fully briefed. Drawing attention too early would have exposed the strategic implications. The first warning sign came from data, not statements. During routine NATO exercises, infrared sensors began recording values that made little sense. Engine heat is one of the biggest vulnerabilities of any fighter, and infrared-guided missiles rely on predictable thermal output. Analysts initially assumed sensor errors. Equipment was recalibrated, alternative systems were used, and the tests were repeated. The numbers did not change. Rolls-Royce had reworked the engine's internal thermal routing architecture. Heat was diffused, redistributed, and managed in ways that sharply reduced concentrated exhaust signatures. The result pushed the Gripen E into a thermal performance range previously associated with twin-engine stealth aircraft. For a single-engine fighter, this challenged long-held assumptions about what was physically possible. The second shift centered on fuel efficiency. Traditionally, extended range requires larger fuel loads or multiple engines, both of which increase weight and cost. By redesigning internal air pathways and optimizing how fuel and oxygen mixed under different conditions, the engine extracted more usable energy from each unit of fuel. The range increase was not marginal. It reached levels that normally require heavier aircraft. This mattered deeply for countries operating across vast distances. Canada, frequently referenced in internal assessments, faces the challenge of patrolling the Arctic, where endurance matters as much as speed. Those missions typically demand large, expensive aircraft with heavy logistical footprints. With the Gripen E's new performance envelope, a lighter fighter could cover similar distances while remaining cheaper to operate. That alone altered procurement calculations. The third transformation involved the digital engine control system. Rolls-Royce introduced adaptive control logic that adjusted thrust output far faster than previous systems. Throttle response became nearly instantaneous. Pilots reported acceleration behavior that felt unfamiliar even to experienced operators. The aircraft could surge forward or disengage with speed that opponents struggled to match. In air combat scenarios, this translated directly into advantage: faster repositioning, quicker disengagement, and tighter control during high-stress maneuvers. Tactical models built around predictable acceleration curves no longer applied. Sweden classified most of the detailed results, but enough data circulated through NATO channels to trigger reassessment. When combined, the reduced infrared signature, extended range, and rapid throttle response produced survivability far beyond the Gripen's original classification. All of it was achieved without altering the engine's external profile. Visually and on paper, the aircraft appeared unchanged. For NATO planners, this was a turning point. A single-engine fighter had effectively entered the performance tier of aircraft, costing several times more. Questions followed. Closed-door discussions took place in Brussels. Sweden confirmed optimization improvements but avoided technical explanations. Outcomes were acknowledged without revealing mechanisms. The deeper truth emerged through internal analysis. A NATO analyst cross-referenced engine vibration data collected during joint exercises. Every engine carries a unique vibration fingerprint shaped by materials and the patterns aligned with Rolls-Royce precision engineering methods. The match was too exact to ignore. This reframed the situation entirely. The Gripen E was no longer just an upgraded fighter. It became a strategic wildcard. Affordable enough for smaller nations, yet capable enough to challenge heavily defended airspace. It demonstrated that advanced performance no longer required entry into the most expensive tiers of aircraft procurement. Concerns spread as analysts realized. Such upgrades leave no visible trail. They cannot be tracked through satellite imagery or standard procurement disclosures. American officials privately described the Gripen E as a disruptive Platform 1 that could reshape how air power is distributed. Further analysis revealed additional layers. One involved airflow pressure modulation at high altitude, allowing stable thrust where performance usually degrades. Interception envelopes expanded. Another involved noise behavior, not audible sound, but acoustic patterns used by autonomous drone sensors. The engine emitted fewer stable frequencies, complicating automated classification, perhaps. The most advanced element was an adaptive thermal management loop. The system constantly monitored heat buildup and rerouted microcooling paths before hotspots formed. Infrared guided missile systems rely on stable thermal signatures. The Gripen E now presented fluctuating patterns that made lock-on far more difficult. Sweden maintained strict compartmentalization. Even within its own leadership, full access remained limited. That decision caused friction as NATO members pressed for transparency. Sweden's position focused on national defense independence. Interest surged. Air forces that once dismissed the Gripen E began requesting briefings and demonstrations. Access to the most advanced configurations remained tightly controlled. Sweden recognized the aircraft had become more than a fighter. It was now a strategic asset capable of shifting regional balances. Ironically, the goal was never confrontation. Sweden sought resilience, independence, and maximum performance without reliance on foreign approval. In achieving that, the Gripen E exposed weaknesses in NATO doctrine. Size, cost, and visible stealth were no longer the only measures of dominance. Internal intelligence, adaptability, and silent upgrades mattered just as much. By the time NATO fully grasped the scale of the transformation, the Gripen E had already crossed a threshold, redefining itself as a lightweight aircraft with heavyweight consequences. Thank you for watching. Like, subscribe, and turn on notifications for more such videos. Your support makes this possible.